Hi everybody, welcome back. This is our last lesson video of Unit 13, and it also happens to be the last lesson video of the year. So, pretty sure today is Friday by the time you're watching this, if you're watching this on schedule. So, Monday and Tuesday are the last, days of school. Monday and Tuesday you're going to be working on the Unit 13 case study, which is pretty cool. But this is the last, video because there are no videos for the case studies. Looking at homework, it doesn't look like Castle Learning number 28 is due tonight by 11:59, and then Castle Learning number 29, the Unit 13 review, it will be due Monday, and then case study will be due on Tuesday. Again, those dates are posted on the website, and that's it. So this is going to go over the more Half-Life practice sheet. So it makes the most sense to try those questions and then to come back if you're stuck and watch for the explanations. So I'm not going to read this all to you because all of you are very capable of reading, and we did spend time yesterday going over what Half-Life is. But the most important thing, and this is why it's bold and I'll highlight it, is that half-life is the time it takes for half the sample to decay into something else, and half of it remains unchanged. So a lot of the questions will ask about, how much is left unchanged, and that's the stuff we're still left with. So there's a great picture on yesterday's note sheet that kind of, went over that. Now the way I broke this down, there are 6 different types of questions for Half-Life, like how they're asked, and they all work the same way, but I broke them down by what they're looking for, and there are 2 questions for each. So if you're still kind of struggling and want to do one with me, then one by yourself, it is structured that way so you could do that. So let's get started. I'm pretty sure I might have showed you this yesterday, but why not include it again? Okay, so the first type of Half-Life question that you might see is a time elapsed question. So it'll ask you, how long something will take. So this one says, how long will it take if 30 grams of 226Ra to decay into 7.5 grams? So one of your first things is to figure out the half-life, and that is 1,599 years, and you don't need to memorize that or anything. This comes straight from table N. Now, we're starting at 30 grams and we are ending at 7.5 grams. I want to know how long that takes. So, if you're starting at 30 grams, after one half-life, you're left with only half of it. So half of 30 is 15. And we want to get to 7.5, so we're not there yet. After another half-life, half of 15, you get 7.5 grams. So, we can see that one half-life happened, 2 half-lives happened. So, if we know 2 half-lives occur, and that one half-life is 1599 years, 2 half-lives is 2 times 1599, which gives you 3,198 years. And that's it. Number 2 says, how long will it take for a 28 gram sample of neon 19 to decay into 3.5 grams? Again, we're going to start the same way. Find the half-life on table N. So for neon 19, it is 17.22 seconds. 0.22. Okay, so with that, we're starting with 28 grams. And so after one half-life, half of that is left, so half of 28 is 14. After another half-life, half of 14 is 7. Still not where we want to be. Another half-life, half of 7 is 3.5. So now, we have one half-life, 2 half-life, 3 half-life. So 3 half-lives occurred. We know one half-life is 17.2 seconds. So all you have to do is do 3 times 17.22, and you get 51.66 seconds. And that's it. So compared to the other one, this one has a much shorter half-life. Okay, next kind of set of questions is talking about the amount remaining. So how much stuff did not decay? And again, our first step, so this says how many grams of nitrogen 16 will be left from a 16 gram sample after 21.6 seconds. So again, our first step is to find the half-life on table N, and it is 7.13 seconds. So the way we're going to approach this, we know how long we have to figure out how many half-lives occurred. So what you want to do is take the total time that elapsed, so that's what this is, divided by the length of half-life, and that gives us the number of half-lives that occurred. So if we know that a total of 21.6 seconds went by, and then one half-life is 7.13 seconds, we can see that 3 half-lives occurred. Now, that, is not our final answer. Now we just know that we have to go through 3 half-lives. So, if we're starting at 16 grams, after 1 half-life, we have 8 grams left. After 2 half-lives, we have half of 8, which is 4. And after 3 half-lives, we have 2. So here you see 1 half-life, 2 half-life, 3 half-lives, and 2 grams remain. That's how that question works. Number 4 says after 9.8 times 10 to the 10 years, how many grams will be left after a 256 gram sample of thorium-232? So here the numbers look a little bit scary, but it works the same way. Step 1 is find the half-life on table N, and so we get 1.40 times 10 to the 10 years. Okay. So we want to figure out how many half-lives occurred, so you take the total time that went by, according to the question. So 9.8 times 10 to the 10 years over the length of a half-life. So 1.40 times 10 to the 10 years, and that shows us that 7 half-lives occurred. So, same way we've been doing them. First, we're starting at 256. After 1 half-life, half of that is left, so you get 128. After another half-life, so 2 half-lives, we're at 64. 3 half-lives, we are at 32. 4 half-lives, we are at 16. 5 half-lives, we are at 8. 6 half-lives, we are at 4. 7 half-lives, we are at 2. So you can see 1 half-life, 2 half-life, 3 half-life, 4, 5, 6, 7. So now, same answer as the other one, 2 grams remain. And that's it. If you are, just to backtrack a second, if you're putting this into your calculator with scientific notation, if you didn't get 7 half-lives, you need to use parentheses in your calculator. And then just practice with it until you get that. But it's June, so hopefully you have learned how to properly use your calculator for scientific notation. Okay. Number 5. Now we're on the next set of questions. This is fraction remaining. So, number 5 says, what fraction of a 100 gram sample of K42 will remain after 28.4 hours? So just like the first 4, our first step is to find the half-life on table N, and it is 12.36 hours. Now, again, following the same method as last time, we first have to figure out how many half-lives happened. So you take the total time that's went by, 24.8 hours, divide that by the length of 1 half-life, So we learn that 2 half-lives occur. And then when we're jumping into the work part of it, when we're asking for fractions, it doesn't matter really how much you're starting with. When we're starting with the fraction, you're always gonna want to start with 1, so a whole. And so after 1 half-life, half of it remains. After 2 half-lives, a quarter of that remains. So you have 1 half-life, 2 half-life, and so 25% or 1/4 remains. Okay. Number 6 says what fraction of radioactive iodine-131 sample would remain unchanged after 32.28 days. Again, find the half-life on table N, which is 8.021 days. Got to figure out how many half-lives occur. So you take the total time that has gone by, divided by the length of 1 half-life, and you get 4 half-lives occur. Again, if you get 4.1 or a little bit, use the nearest whole number. Okay, and then since we're talking about fractions, we're going to start with 1. After 1 half-life, half of a whole is half. After 2 half-lives, half of a half is a quarter. After 3 half-lives, half of a quarter is an eighth. And after 4 half-lives, half of an eighth is a 16th. And again, we see 1 half-life, 2, 3 half-life, 4 half-life, so 1/16 remains. Okay. Next, we are halfway done. With this, we have 6 more questions and 3 more question types. Now, if you haven't noticed, you can probably hear like little birds in my backyard chirping in the background. I have no idea what kind of birds these are. So if you're like super into or really good at, bird identification, I would love to know what lives in my backyard. Anyway, number 7, the next set of questions goes over the number of half-lives. So these are the simplest types of questions. So number 7 says how many half-life periods will it take for 50 grams of TC99 to decay into 6.25 grams. So if you wanted to, you can pull this off, the half-life off table N, but that doesn't help you. It says we're going to start with 50 grams, and we're going to end with 6.25 grams. How many half-lives does that take? So if we start with 50 grams, after 1 half-life, half of that remains, that's 25 grams. After 2 half-lives, 12.5 grams remain. And then after 3 half-lives, 6.25 grams remaining. So all this is saying is, well, how many half-lives did you go from here to here? And that's 1, 2, 3. So 3 half-lives occurred. Now the other questions that we've done and will do kind of take an extra step beyond that, but this is all this needs to stop by. Okay. Number 8 says how many half-lives have elapsed if a 100-gram sample of radioactive isotope only has 12.5 grams remaining. Now this doesn't even tell you what element it is. Again, doesn't matter. We are starting with 100 grams. So after half of 100 is 50. Half of 50 is 25. Half of 25 is 12.5. And that is where we are ending. And then we have 1 half-life, 2 half-life, 3 half-life. So 3 half-lives occurred, and that's it. Second to last section, the original mass. I personally think this one is the most challenging, just because you have to kind of work backwards, but it's not hard compared to other things we've done this year. So number 9 says if 2 grams of original sample of gold-198 remained after 13.5 days, what was the mass of the original sample? So the half-life, you need to go back to table N. Half-life is 2.695 days. And we have to figure out now how many half-lives have gone by. So again, you take the total amount of time that's passed, divide that by the length of one half-life, and you get that 5 half-lives occur. Now up to here, we've done this. Now this is what I mean by work backwards. So it tells you, up until here, we've been given what we've started with and asked, what the final amount was, right? Or it said we were given the initial and the final and told you, how did we get there? Here, we're given 2 grams of it is what we're ending with. So you have to kind of go backwards and figure out, well, where did we start? Let me get rid of that. So, and we know we have to go back 5 half-lives. So before it was 2 grams, it was 4 grams. So when we're working backwards, instead of cutting everything in half, we're going to double it. Before it was 4 grams, it was 8 grams. Before it was 8, it was 16. Before it was 16, it was 32. And before it was 32 grams, it was 64. So this is what I mean by kind of working backwards. Normally, I would give you 64, and then we do 1, 2, 3, 4, 5. But here it gave you the final. I want you to figure out where you started. So 64 grams is how much you started with, and that is it. Okay. Another type of this question. Half-life of this is 7.4 times 10 to the 8 years. We have to figure out how many half-lives occur, so you take the total amount of time that has gone by, 2.84 times 10 to the 9 years, divided by the length of a half-life, which is times 10 to the 8 years. We get 4 half-lives occur. So again, that's not your final answer. And it says, we're ending with 16.5 grams. Oh, I don't think I read this question. I don't remember. It's okay. Okay. So we're ending with 16.5 grams, and we have to go back 4 half-lives. So, before it was 16.5, double that is 33. Before it was 33, it was 66. Before it was 66, it was 132. And before it was 132, it was 264 grams. So here, we go 1, 2, 3, 4. We have our 4 half-lives. 1, 2, 3, 4. But here we just work backwards. So 264 grams is what we started with. Okay. Number 11. And this is the last set and the last topic of these types of questions. Now we're looking for, what the length of a half-life is. So here, table N will not help you because they will give you elements that are not on table N. So 11 says an original sample of a radioisotope fluorine-21 has a mass of 80 milligrams. Only 20 milligrams of the sample remain unchanged after 8.32 seconds. What is the half-life? So, the way we go about these types of questions, you have to figure out, how many half-life. We're given the total amount of time that has gone by. And we know where we start, we know where we end. So we have to figure out how many half-lives occurred, and then divide that by the total time. So, we're starting with 80 grams. That's where we're starting with. We want to end with 20. So half of 80 is 40. We have to do it again. Half of 40 is 20. So here, we see we've done 1 half-life, 2 half-lives. Now, in order for this to happen, it took 8.32 seconds. So what we know is that 2 half-lives equals 8.32 seconds. 1 half-life is equal to, and then you just take the total time divided by the number of half-lives that occurred, and you get 1 half-life is equal to 4.16 seconds. And that is it. Number 12, the last one for the day. It says, what is the half-life of a 208 gram sample of sodium-24 if it decays to 13 grams of sodium-24 within 60 hours? So what we care about is what we start with, what we're ending with, and the total time that has gone by. So we start at 208 grams. After 1 half-life, 104 grams is left. After 2 half-lives, 52 grams is left. After 3 half-lives, 26 grams is left. And after 4 half-lives, 13 grams is left. So we've done 1 half-life, 2 half-life, 3, and 4. And it took 60 hours for 4 half-lives. So we know that 4 half-life is equal to 60 hours. 1 half-life is equal to 60 divided by 4. So we get 15 hours. And that is it. So I just want to leave you with this. Now, since this is the last video, this is my last opportunity to kind of make this announcement. This is the end of the year, so make sure that you do have all of your missing assignments in. The marking period does end pretty soon. I think if you're watching this on time, it ends next Friday. So if you are missing anything, finish them. Let your teacher know. If you have questions, ask them, and have a wonderful time. Wonderful day, wonderful everything. Goodbye.